Hi, my name is Chaitanya and I work as a data scientist at EC Infosolutions. So in this video, we'll look at what AWS SageMaker is and how we can use AWS SageMaker to create and deploy a model on the cloud. So in this video, we will cover what SageMaker is, what is the SageMaker notebook instance and how to create one. We'll take a customer churn problem and then create an ML model. We'll also look at what different deployment options are available, and we'll create a live endpoint on which we will deploy our model. We will also then serve predictions from the model to complete the process. The things which we will not cover in this video are what is AWS in general, how to create an AWS account, what are AWS services like IAM, S3, ECR, Lambda, and CloudWatch, and the theoretical details of ML algorithms and the machine learning process. This video's main motive is just to let the user know on how we can create a ML model on cloud. So first, we will navigate to the AWS SageMaker console. So there are multiple sections on the left. In this video, we will be covering the notebook, processing, training, and inference sections. The augmented AI, AWS Marketplace, and ground truth sections are not covered in this video. So there are two. So what is AWS SageMaker? So there are two main advantages of AWS SageMaker. Apart from many small advantages which it provides. The first main advantage is that it very quickly creates a pre-built Jupyter environment for us. The data scientist does not have to go through the hassle of installing the machine learning libraries, dependencies which are required for data science. With a click of a few buttons, we have a good cloud environment ready and running to start our data science experiments. The second advantage of AWS SageMaker, as which we will see in this video, is that it manages the whole process of training the model, deploying it, and gathering the inference. In the traditional method, we have to create a model and then save it as a pickled file somewhere at a location, and then retrieve that model to gather predictions. AWS SageMaker does exactly this process for us in an expedited way. It also allows us to create a live endpoint, which enables us to get predictions 24/7 and plug and play it with different web services. So without further ado, let's dive into how we can create a notebook instance and start doing data science on SageMaker. So we'll navigate to the notebook instances section. Under the notebook section, here we can see that there's a notebook instance of type MLT2 medium, which is already running. Since the creation of notebook instance takes a long time ranging from 5 to 15 minutes, I decided to create it beforehand. I'll just quickly run through how we can create a notebook instance in AWS SageMaker. So I'll click on create notebook instance and then enter a few details like the name. I'll select the instance type. To get more details about different instance types, we can go to this page. So we can see that if our use case demands a bigger instance, we can easily see the configuration here and then choose a big instance if we want. And within minutes, it will be up and running. So this is the power of SageMaker, and it will also provide a pre-built Jupyter environment, as we will soon see. So after selecting the instance type, we'll keep everything as is. There is a thing called as IAM role, which I've created right now, and I've called it Amazon SageMaker execution role. But if you have not created it, then you can easily create it by clicking create a new role and then clicking create role. But I'm not going to create it right now because we have already created it. And rest all options, we will keep them as is right now, and we will click create notebook instance. So another notebook instance is being created. So we'll leave that to be created and get started on this instance, which is already in service. So this is how the Jupyter environment looks like. If we go to new and navigate to terminal, we can see that there's a Linux terminal which is available to us. So essentially this is just a Linux server, and we can run bash commands on it if we want. So on top of this, we have this Jupyter environment, which is up and running. There is also a tab for SageMaker examples in which AWS provides us with ready to use and learn examples of how to use SageMaker. So in this video, we are going to use the XGBoost customer churn example. So we'll just navigate to Introduction to Applying Machine Learning tab under AWS SageMaker examples and click on the Use XGBoost Customer Churn button. We will save the copy of this with a different name and we'll create the copy. We can see that SageMaker opened the copy of that notebook and is asking us to select the kernel. Kernel is nothing but different Honda environments in which we can run our code. Each environment has a different set of packages of different versions installed on it. For example, we can see Conda Python 2 environment, which has Python 2 installed along with the Anaconda ecosystem. There are other environments for various deep learning packages such as MXNet, PyTorch, TensorFlow, and so on. We will select the most regular environment for doing data science, which is Conda Python 3, and we'll set the kernel. So we can see there are different sections in this notebook in which the author has provided us with various details. I won't read each section word to word, but we'll just run through the important details and contents. The main goal of this notebook is to actually create and deploy a model and not to dive deep into the data science details. So we will just stick to high level explanations of what the problem is and what the code is doing. So first we will import a bunch of dependencies. SageMaker module in Python is a high level SageMaker API to run the ML workloads. We are also importing Boto3 package, which is a very useful low-level AWS Python API. We will get the role, which is an IAM role, which is required to process the data. If user is interested, one can check the individual details of this code. But for now, we are just going to point out that they are dependencies and move on. Then we will import a few ML packages like pandas, numpy, matplotlib, IO, and so on. Then we'll download the data from this link and take a look at what the data is. So this is a data of customers of a mobile network provider in United States. So each row represents a customer profile and whether this customer has left the network provider or not. So that information is given in this churn question mark feature. False implies that this customer has not left the network, and wherever the value is true, it implies this customer has left. So using this data, we are going to create a model to predict whether a customer will leave our network in the future, or how likely is he or she likely to leave our network in the future. So that once the model points that out, the company can take a corrective action based on that prediction. These are just the details of the features. If someone is interested in looking these up, there is a GitHub repository in AWS Labs account under Amazon SageMaker examples. In this section, if one navigates to Introduction to Applying Machine Learning and navigates to Customer Churn, XGBoost Customer Churn, they can have access to the notebook and dive deep into the details if one needs. So we won't be doing that here. So these are a few more statistics which are being calculated. Things like how many percent of observations are there in each category of a variable and so on. So here we see state variable, and we are looking at how many percent of observations are there in each state. So to look at the important variables, the variable which we are predicting for, the churn question mark, has 14% churners and 85% non-churners. And there are other variables like how many minutes has the person talked over the network in a day, in the evening, how many calls, and what was the dollar charge, and so on. So we'll drop the phone variable from the data because phone variable has many unique values, and in ML, if a variable has a lot of unique values, it's not useful. And then we will do some basic data manipulation with changing the type of area code and so on. And in this notebook, we can also calculate more statistics, this time comparing the churn question mark variable with all the variables we are using to predict the churn. So we can just quickly look at an important example in this and move on. So international plan variable is interesting because among all the people who churned, there were around 30% people who had an international plan. And among all the people who did not churn, only 6% had an international plan. So this indicates that maybe there is a high likelihood or more likelihood of someone having an international plan to be churning than someone who hasn't. And then there are other graphs and charts which explore the data more, which we'll just skip for now. Again, the author points out to a few characteristics which one can look at this GitHub notebook page. We'll skip this section. This section basically checks the correlation of all the features. So in machine learning, if features are highly correlated, but then we need to remove those. And as a result of this notebook cell, we remove these 4 features from the data as they are very highly correlated. Now we will turn to the data preparation, in which we first dummify the categorical variables. We then concatenate the variable to be predicted, which is churn question mark, and all the other variables in the data. We do this because SageMaker needs the data to be in a particular form. And that form is that the variable to be predicted should be first in the data, and the data should not have a header row. So in the subsequent cell, when we save the data back to S3, we basically remove the header. So header is equal to false and index is equal to false, removes the index as well as the header, so that we get the data in the form which SageMaker requires it to be. So just to repeat again, SageMaker requires the training data to be in the form where the variable to be predicted should be first and there should be no header. So we'll run this. Here we've split the data into 3 data sets. As we know that in machine learning process, we first train the model on the training data, and then we need to validate the results on the unseen data. Sometimes we only create one file for the unseen data, but in this case, we've created 2 files and we've called them validation data and test data. We save the train data and the validation data, as pointed out, without a header. And then we upload these 2 files to S3. S3 is just a storage facility which AWS provides. It's like a big hard disk with different folders. We can quickly take a look at our S3 folder. So we can see that we have one bucket, and in that we have our train and validation data saved. One folder called as output is also created later on to save the outputs. Now we will train the model. So to train the model, we will use something called as a container. So container is a software which defines the environment dependencies so that our code can run successfully. SageMaker has pre-built containers from which we can just pull the container image. So here, using this get image URI function from this module, we are going to pull an XGBoost container image, and we will save that into the container variable. We will then create a S3 input data type for train and validation. So this is just a SageMaker's abstraction which it uses to push data into the training process. We will then select a few hyperparameters, but before that we will create the estimator object in which we will input the container, the role which we are using, and a few more details like the output path and the instance type we want to use for training. We will also use the session object which we created in the first cell. Then we will set the hyperparameters by using the set hyperparameters method on this object, and then we will actually fit the model by passing in this input S3 input objects which we created in the previous cell. We can see that the training job has started. And if we go back, if we navigate back to the SageMaker console, and if we go to training jobs, we will see that one training job is in progress. So this is the training job which SageMaker is running for us, and it will save the model artifacts at this output path which we provided. In this process, SageMaker is essentially packaging the model like we use a pickle file to save a model to the disk. SageMaker is doing it in its own way, packaging it and saving it to this output path. In some use cases, we can also save the pickled file and then retrieve it to generate inferences. So we can see that the training of our model has been completed. So let's go back to our notebook. We can see SageMaker printed out a bunch of details here. Since we had used a XGBoost model, which is a tree-based algorithm, we got a train error and a validation error when each tree was fit, and our model ran for 99 iterations and then exited. SageMaker also lets us know the number of seconds which was used in training the model and how many of them will be built. So then we can compile our model. Compilation of model is something which optimizes the model to run very quickly. Since we are dealing with a small data set, we do not need to do that. but it's a nice SageMaker function to have when our model is large. The next thing which we will do is this model which we have created, we will host it on a live endpoint to which we can send post requests and get the predictions. We can do this in one line. So our model is called as XGB. So we'll just do xgb.deploy. Select the number of instances we want the model to be deployed on. Since our model is very small, we will choose one. And we will choose ML M4 X large, which is the smallest deployment instance which can be used on SageMaker. So we'll go ahead and run this. Deployment takes a while, and we can immediately navigate back to the AWS SageMaker console and go to endpoints under the inference app. And we can see that there is a endpoint which is being created for us using this model. Other ways in which the model can be deployed is that one can save a pickled file back to S3 and call it to generate inferences. We can also use batch transform jobs in which we can run batches through the model and get predictions. So there are multiple options available, and depending on our use case, we can choose those options. So we can see that an endpoint has been created for the model which we created. Now we will get predictions from this endpoint. So we need to define a serializer and deserializer, and the data which we push should be of text or CSV format. So we'll just quickly define this. And then in this predict function, we will simply loop or test data set, split it into mini batches of rows. Then we will convert them into CSV strings. And then once we invoke the XGB predictor endpoint, which we defined previously here, we will gather them as CSV strings, and then we will convert them into a NumPy array, and we'll store them in this predictions variable. Now here we calculate the confusion matrix of the predictions and the actual observations in the test data. So we can see we have 43 observations which our model has predicted to be churning. So there are 43 customers which our model thinks may churn. Out of that, 39 are true positives. It means 39 out of 43 our model has correctly predicted to be churning, and 4 it has wrongly predicted to be churning. And out of the predicted customers who are not going to churn, the total of these predictions are 291, and out of them 282 have been correctly predicted and 9 have been wrongly predicted. So this model is a pretty good model and is giving us pretty good results on the test data set. And then we can basically summarize the predictions and do further analysis by changing the thresholds and also creating the cost associated with our models. But since we are not getting into the data science part, we won't dive deep into this. So this is essentially the end of the video. To summarize, we saw first a high level overview of what AWS SageMaker was. We also saw the different advantages and functionalities which AWS SageMaker provides. And we went to the two important functionalities, namely one of using a notebook instance and a pre-built Jupyter environment on which you can run your data science experiments. And the second one of training and deploying a model using SageMaker service. So this is it for this video.